What we've got here is a Solax grid-tied solar inverter. So basically means you can connect it straight up to your grid and a bunch of solar panels. You don't need battery backup. You just supplements your mains usage, and anything you don't use feeds back into the grid, depending on what sort of meter you've got. Will depend on whether it runs backwards or not. This one was on a digital smart meter, and it would just stop. It wouldn't actually run backwards, but there are ways that you can get credited back for the privilege. Anyway, this one got water in it, which for an IP65 rated outdoor unit is not really good. It's only a few months old. So we're going to pull the lid off and see if we can find out how the water got in, and maybe remedy the other one that we've got. If it's a design flaw, maybe a lack of sealant in assembly or something. You can kind of see it squeezing out around the edges of the front panel here. On the front, it's got three lights. It's got an LCD for information and one large button to go through the different monitoring information. I don't think you can do a lot of setting from the front, or can you? It was a while ago when I put it on. Anyway, yeah, let's crack into it. The spec sticker on the side can run up to 580 volts DC panel voltage, and supply continuous AC power of 4 kVA. At the bottom on the left, we've got our solar panel connectors. There's A plus and minus and B plus and minus. You'd have two even strings of panels, and in the middle there's a panel that I've already removed just to see how much water was actually in there. That covers a communications connectors, and another hole to the right is a Wi-Fi, which has a little antenna that sticks out through a gland. I think this one's fallen inside at the moment. And then the mains connector on the right hand there, and on the very left, beside the solar panel connectors, there's a cover, and I don't know if you can pull that cover off or if it's an option of some sort, but it says off and on. I think there's a contactor in behind there, but I'm not 100% sure yet. I'm guessing that some models you can actually have a switch option so that you don't have to install a external isolation switch. Right, let's hit these screws. There's 4 down each side. Right, it'll be interesting to see how well stuck on this is. If there's any sort of you know, assisted sealing, or if it's just going to fall off. Start at the bottom. I can feel the corner lifting there and there. Okay, so right away I can tell that the front control panel is actually stuck to the top of the case there. The LCD is coming up with it. What have we got? There's some cables. Alright, I'm going to have to unplug some cables before this will come off. Right, just some silicon holding the connectors on, so we can now lift the front cover away, and voila! I'll just pop that there. You can see the front panel held in, and three flat ribbon cables there, and lots of moisture. This thing is completely wet, like someone just turned on a hose inside there. there is not really many areas that are dry. It's all probably from evaporating and condensing back onto surfaces, and it's just absolutely covered, but nothing immediately obvious as to why isn't turning on. Oh, yes there is. I think we've got some blowing semis. Anyway, as you can see down in this corner here, there's no contactor or anything, so it must be an optional switch. And there's the point of failure, folks. You can see how the seal has been pinched by the lid during assembly and completely cut. And I'll show you what on the lid actually did that, because the other side's okay. In the lid here you can see this, I guess it's just bracing really. I don't know, it doesn't appear to serve any great purpose, but square end of section, and that's obviously come down hard during assembly and torn the seal. So yeah, it's a bit unfortunate. So let's have a little bit of a look at the flow of things and the layout of the board and so on. In the end here we've got our solar panel input. We've got our input capacitors, and from there, not too sure what they are, comes into these inductors, and there's 4 of these large inductors, and there's 2 wires in and 1 out. There's a single, oh no, sorry, there's 2 black wires out, 2 red in, 2 black out. They come down to here, and there's, so it looks like 2 input inductors. From there we've got these must be our output capacitors, and all of the switching transistors are hiding under here, bolted down to the heatsink, and that appears to be where most of our damage is. If we zoom on in, there's some very definite charring emanating from under there, and it appears to be about the only one. Now I did hear, when it was attempting to connect to the mains and start up, I heard a rather loud pop, and I actually heard it a couple of times, so I don't know if it was the large inductors kicking, because it actually sounded like a contactor. That's why I thought there might have been a contactor down in that corner. It vibrated the unit when it happened, so it must be these inductors kicking as the load takes hold. Got a 30 amp fuse down here. The breaker that we stuck on the power board was a 20 amp, which is about all that this will supply anyway. These transistors here and here looking like our main switching transistors, and looks like the output would go through these inductors back down through here, and that looks like that couples into the mains side of things that runs down this side here. Just notice that here we've got 4 relays, which will be for isolating the mains until the unit has done its power up testing and is happy. It's probably what I heard clicking in and out, or be at least part of it. Down here at the mains input end we've got some, what appears to be a current transformer, and a couple of traces running off from, we've got here and here, coming up in here, possibly for monitoring of the supply current for to prevent overload conditions. Possibly also monitoring of the phase, because I'd imagine when this thing kicks in and to supplement the power usage, it would have to be in phase with the grid supply as well. So I would think it monitors that and times itself, gets that all synced up, and then kicks it in to help out. But that could be what these relays are for as well. It'll probably monitor that, and once it's got it switching in sync, then it probably activates those relays. But I honestly don't know for sure. Here's the Wi-Fi antenna. How's that for a cute little antenna? Perfectly wound to suit the frequency, I'd say. Not just a random bent bit of wire. That just pokes out through the bottom through a gland, just to provide some weatherproofing. There really is a lot of moisture everywhere. I think next step I'm going to pull this thing apart. We'll take the board out and we'll see just how bad that soot up the top end is, and whether it's just burnt from the PCB, or whether that FET or transistor or whatever they've used is exploded. Because it'd be interesting to really get this going again. I've asked the owner and he doesn't want to send it back under warranty. If it was me, I would. But he's just keen to see if it's fixable. So here we go. Right, I've just removed all the screws and these caps that sit over the FETs and hold them down onto the heatsink, and I thought that they were ceramic, but they're just plastic. They really do look like the white ceramic that the likes of your power resistors are coated in. But now the board's free, so we can flip it over and see the damage. And there's one of them, folks. They are not supposed to have a crack through the casing, nor should they be surrounded by a black soot. And if I can get over here in the right angle, you might even see that one. It also has a big crack in the casing. But luckily that appears to be the only two. That's not to say that the others haven't shorted, but they're the ones that have actually shown the fact that they've shorted. These wires, the terminals on the end are quite a tight fit onto the board, and luckily they've been kind enough to label them. And where it says it's got 4.4 KP01, the P01 matches the P01 on the printed on the board, so no trouble with reassembly and having to remember where everything goes. I've measured where I can with a voltmeter just to make sure that these caps are not holding a charge. I mean, as you'd imagine, there's no chance a submerged unit like this is probably holding a charge, but you just want to be sure, especially when there's sort of the possibility of 500 volts worth of input voltage hanging around, or even 300 on the output. Here we go. Oh, there was also this lead in the middle that goes down to what I'd pretty safely assume to be a thermocouple mounted on the heatsink. So actually I have to untangle that from the board first, don't I? I might just keep going until I reach the end of the heat shrink and then get the wires out. Wires aren't as fat where there's no heat shrink around them, so they slip through the cutout in the board easier. Voila! Now she's a hell of a lot of water in the bottom there, but it's only because it's been lying on its back and allowed to float around. But yep, no, the underside's looking just as wet, but no sign of corrosion. on anywhere actually, it's quite interesting because this was still running off the solar panels. The LCD was still giving a readout. It was only failing when it tried to kick in the inverter. So yeah, I would have expected some corrosion like you might find in a cell phone that got full of water. They rot up pretty quickly. But no, not on here. The only thing I've seen that could be an issue, possibly, here's the communications board, and it sits separate to the other in the case, and it's just got a little plug onto the main board, serial comms, and that has a little bit of possible discoloration, but nothing that I'd really be concerned about. So yeah, it's quite interesting. There's no, I don't believe there's a conformal coating on this board. It doesn't really look like there is, but I suppose there could be in some parts, but yeah, not really obvious, not thick anyway. Let's peel off this here and have a nosy. Ah, look at that. In fact, it's so good, I'll take you in for a closer look. Completely blowing one leg right out of it. As you can see, the one beside it only has two legs, so that's just going to be a diode. Now we'll have a look at the other one there. Lovely. Oh yeah. And that one still has its legs intact, but it's certainly made a bit of a mess. Let's just fold that over. Have a look-see. Ah. Ginormous crater. Now what are these? While we're looking at it. Oh, yeah. Ta-da! It's done a perfect job. So this is a G47 N60E. So we'll be able to look up the data sheet on that one and see if I can find the same, if not equivalent or suitable replacement. But I think I'd want to match them in a high-powered device like this. I'd want to use the same all round. In fact, even if it was just like $20 a pop, it would be worth replacing the lot of them, even if the other ones did test okay. Having a look under these ones, they look alright. That's not discoloured, that's just a lot shinier than these. These are quite a matte surface, and this one has quite a shiny surface. Yeah, they don't look too bad either. We shall pull out ye old voltmeter and make some measurements. And for those that are wondering, it appears that they've used Nippon Chemicon capacitors right throughout, so spared no expense, and a fairly well built unit. Okay, so let's have a look at these transistors now and see if we can't see if the remaining intact ones are any good. You can see that. There we go. So we'll start down here. We've got one of these FETs of the exploded variety. The hang on, here we go. G47 N60E, and we've got our gate, drain, and source. And from right to left, we'll just poke a lead on there. See what we get. Now these are still in circuit, but I've removed the inductances, so I'm hoping there'll be nothing in the circuit to imitate a short. But we may, if there is any, we may have to pull it out to verify. So that looks like a gate drain source to me, and a gate drain short and a gate source short. It's not too flash to start with, and we've got a drain source short as well, but given what's happened here, I'm not surprised. The next one beside that is an IXYS fast recovery diode, and we're looking at that way around, I believe. Yeah, that looks like a standard fast recovery diode drop, and then there's another one beside it here, which that looks okay as well. We've got one more of these FETs here, so we'll just have a look at that. Gate to drain. Now that looks okay. Gate to source, that's alright. Drain to source. Now there is a reverse diode across the drain and source, so that looks like that there. And if we switch the leads over, well, we can also see a diode. Okay, so maybe I've just turned this FET on by probing its gate and source. Let's just short those out there and see if we can get rid of one of those. So that one's still there. That one's still there. Either that or I'm measuring across something else in circuit. Right, now the other transistor is a Infineon IKW75N60T was the number I came up with just looking at the number on the transistor, which is only, what do we got there, K75T60. That's what I got as a result, so I'm hoping that's correct. And what it is a IGBT, like a transistor where you've got base collector emitter. This is like a hybrid, so we've got gate collector emitter. I learned something today. Haven't had much to do with IGBTs myself. So that also has a reverse diode across the collector and emitter, so we may end up measuring that as a result. But there's our gate to collector short, gate to emitter looks shorted as well, and looks like a dead short, not even a diode drop across the collector and emitter, unfortunately. So I think that one's out to lunch as well, and I've got one more on this side to check and make sure we get a connection, because there is, like, I think it might be a flux hanging around on the board with nothing going on there, I don't think. Yeah, that's working. So there's our reverse diode across there, something else in circuit across there, and nothing. Just make sure I am getting good contacts. Yep, so the gate is not shorted to there, so that one's out to lunch for sure. So we could be up for a few transistors to get this thing repaired again. That's right, there's some more on the other side here. Alright, just along here and here. Not 100% sure what they do as yet. Need to study the circuit more, but they appear to come off the input capacitors. So we've got our up to 580, I think the sticker said, solar panel voltage in. Comes through here. And yeah, we've also got some rather large surface mount looking FETs as well, so they may just be used as switches to turn on the voltage from the panels to allow it to flow through to the rest of it, because they do appear to be two in series there and two in series up here. But in fact, the way they're soldered in with the legs joined, I'd say they're just acting as diodes. So if we probe on these surface mount devices, they appear to be diodes like I thought. That one's okay. That one's okay. That one's okay. Now down here and here we've got another one of those excess diodes, which looks okay. That one looks okay. And then we've got in the center we've got two more of the 47N60 FETs. So if we go now gate drain on there, yeah, that looks fine. That looks fine. So nothing shorted there. And then we've got another a different package that I haven't actually identified yet, but it's still a transistor, so it's still going to be not looking for a short on the input. But I'm pretty much confident that all these input ones are okay, because as I said, it was running off the solar panel voltage, and it was only failing when it went to kick in the mains there. So as we saw why. Come on. No. Here we are. Alright. Cool. Okay. So, I'll conclude at this point and say that we need some switching transistors, and hopefully I can get a local source for them, but if need be, I suppose I could order online. It's not like this is going to be used in a great hurry. There is a backup unit running in the moment. So, yeah. Thanks for watching. Hope you found this interesting. I will definitely keep you informed. We'll make another video if I can progress with it. And I'll even catch the first power on film for you lot as well. But I think the next step is sit in the oven for a while and dry things out. Catch you later.